everyone, 13 News meteorologist Sean Ash here to talk about my favorite topics in weather: lake effect, snow squalls, and football being played in the snow here. You gotta love it. Of course, this is back from the 1st of December, that 49ers Buffalo Bills game, and usually we get at least one doozy from Buffalo come December. That was the case this particular season. Of course, Buffalo gets quite a bit of lake effect. This one just happened to be occurring during that Sunday night game, and it was fantastic. You see Josh Allen there diving. You can see that snow packed in. And, you know, in Buffalo, they have the fans help shovel out the stadiums to get it ready here. And this was the scene. You can see just how much the stadium got, which is just south of downtown Buffalo, but they had a little more than 2 feet of snow with that particular event. So I want to talk about some of the big lake effect cities, not all of them, but some of the big ones, kind of compare their averages to some of their record years and how that compares to us here in the Midwest in Indianapolis. But let's take you up to Marquette. Nearly 150 inches per year. Their record snow was back in 2002 and 03, and just shy of 300 inches of snow. We mentioned Buffalo, roughly at about 95 inches. That's their average, and their record was from the winter of 1976 and 77, almost 200 inches. Now, compare that to our average in Indianapolis, which is near 26 inches. But even our record snow winter that we had from 1981 and 82, where we were just over 58 inches, even our record doesn't compare to the averages from these cities. So let's talk about what makes the lake effect. And it is wind and it is water. Those two components here. And through early December, you can see we are off to a very quick start to the lake effect season here. Okay, there's Ontario. You see downwind to that. When we say downwind, the predominant wind in winter is generally west to northwest. You deviate that vector, and that can really change who gets the big hits. Northern lower Michigan and the UP. Look at Sault Ste. Marie, already over 40 inches. Over 30 inches in Lake Erie. What you're seeing here across the Midwest, that is not lake effect, though we can get some lake effect, depending on the wind vector. If we have a due north wind, we can get some of that lake effect moisture way south of the Ohio River. So this is all good news. This is healthy snowpack for these communities. That a lot of them, you know, that's part of the livelihoods during the winter months. So this is through early December, and what's going on so far is that the Great Lakes, many of which near, if not record warm temperatures, and then we had that early intrusion of unseasonably cold air go over those very warm waters, and voila, we get lake effect, and these are what we call the snow belts, okay? Areas that are just downwind. So Cleveland, Erie, Buffalo, Watertown, Sarnia, Alpena, Traverse City, Petoskey, Sault Ste. Marie, Marquette, Muskegon, Grand Rapids, South Haven. Now, this is the predominant wind direction during winter. That's not to say that you may not get it like sometimes, depending on if you have a low that's tracking near Chicago, you can get an easterly wind that hits Milwaukee and can drop a heavy snow load there. But these are the predominant lake effect snow belts within the Great Lakes. And this is just an example of how that wind direction can play a role. Prior to this satellite and radar animation, it was more of a north wind down Lake Michigan and actually dropped some snow into South Bend, which is not uncommon at all. In this particular recording here, though, we've got a southwest wind. So that's cut off the main moisture tap, but now that southwest wind is going to shift the direction of the lake effect. So it's always very fascinating. Now, we mentioned the water and the wind creates this, and you can just see this. So this is a computer model animation, and you can see those lake belts just lighting up depending on the direction of that wind here. So we'll get into the science of this. That warm water, and keep in mind, these lakes, we call them great for a reason. They are massive, and some of them are deep as well. Water takes longer to cool down and longer to heat up. So until the lakes freeze over, that warm, moist air is available for the cold air intrusions. Now, once they freeze up, the lake effect season is essentially over, okay? But this is how it works. The ground is going to be colder. Take that cold air over it, all right? We mentioned the wind flow. We don't need a lot of wind shear because that can disrupt the bands. And when you have more of a steady wind that's moving over, not too strong, and then boom, you get the moisture starts to rise, it forms into a cloud, and then what will happen is it will come what we call downwind. It will get into the lake belts, and when that happens, that's when we start to get those areas of snowfall. And a lot of times these things can be rather shallow. These aren't very tall. Now sometimes they can be a little bit taller, but generally these are shallow cloud tops. But depending on the intensity, and what I mean by that, the difference in the temperature of the water and the air mass above, this can get very unstable to the point where we can actually have thunder and lightning with some of these lake bands. And they can be very narrow. And you can go north or south or east or west of these bands, however they're set up, and you may have hardly a snowflake. But then you get caught within the lake band, and you're breaking your back trying to shovel 3 or 4 feet of snow in one particular event. So again, it's all wind and it's water. Now, sometimes, again, that difference in temperature and air mass above can be strong enough to create something that we call lake effect squalls. Now, those can get very, very dangerous because they can cause whiteout and very, very intense snow rates in excess of 2 or 3 inches per hour, depending on the atmospheric conditions. Kind of a similar setup to just run-of-the-mill lake effect. But these squalls can do some significant problems to the roadways here. So kind of talk about that. You see those things build up that lift along an Arctic boundary or a strong front, and lifts that moisture up and then takes it downstream, and that's where it drops. Now we can get these squalls forming in a couple of different ways, and you don't have to be around a lake to get snow squalls. Even well away, if you have a strong enough Arctic front, that can create squalls as well. So basically that Arctic air, the Arctic front, really, really cold air separates what's in advance of it. And it's similar to kind of a springtime cold front that forces the air up and creates thunderstorms. Well, in this particular case, it can form areas of very heavy snow, very heavy bands of snow, and we call them squalls here. And what we have discovered over the past 10 to 20 years is the squalls can be, unfortunately, deadly on roadways here because they essentially can create rapidly changing road conditions. When do we have snow squalls? Anywhere from autumn to even early spring. And again, it doesn't have to be around a lake. We can get them across the Midwest here. So this is an example of what a squall may look like. You might have a completely blue sky, and then you get within the squall, and that can happen over a short distance, less than a mile. All of a sudden you're in this, an intense burst of heavy snow. Now they're usually short in nature, half an hour to an hour. Visibility quickly reduces to whiteout, and the road conditions go from completely dry pavement to this here. And that's why they are so deadly, because they can cause these large pileups on roadways. If you're ever caught in a snow squall, we always recommend during the winter months, kind of look at the road conditions before you're heading out. Last thing you want to do is slam on the brakes, put your headlights on, allow extra time so you're not racing to get there. And very important to monitor local forecast and travel conditions before heading out. So the difference between a squall and a winter storm, winter storm, we're seeing this thing come out days in advance, and it might last, multiple hours to a day, whereas the squall is going to be about a half an hour to an hour in duration, generally. We might know, 48 hours in advance where we might have the potential, and then when we get closer to the day of, then we're essentially radar watching. And then you may get into a situation, and the National Weather Service will be issuing these. These are called snow squall warnings, and it's similar to a tornado or a severe thunderstorm warning because they are polygon based. And the idea is to prevent these high-speed accidents and the large pileups that cause injuries and unfortunately some fatalities. So do us a favor, make sure that you have your phone activated to get these warnings, because they can prevent you or at least alert you that you could be driving into an area or you're within an area that is under a snow squall, and hopefully it can save some lives. We appreciate you checking us out here on 13 Plus. Take care.